This is Jeetan. In prior developer beginner trail video, we started on Salesforce development basics and covered flow builder basics. We also looked into formulas and validations with these trail modules. Then for the programmatic and complex Lightning components backend development with Salesforce data, we start on Apex basics, understand Lightning web component basics, and then we can delve deeper a bit once we complete these modules. And let's look into this a bit. So Apex is like any other object-oriented programming language which supports classes, interfaces, inheritance. It is strongly typed, and but what you get with Apex is it runs on Force.com platform, and it's unlike other object-oriented language. Cloud development as Apex is stored, compiled, and executed in the cloud, and you have triggers. Then you have DML statements, which with which you can make direct database calls. An S object, either a generic S object, is is uh, is how the objects, Salesforce objects, are represented in Apex, and each record is an S object record natively in Apex. You can create less and you can create Apex classes through developer console, and then run them through the execute anonymous block. So let's simultaneously open one of the hands-on org. One sec, let me do that in the another window. Let me launch that developer org. And this is how we can access the developer console. And when we follow along this trail, it gives the code snippets which we can run in developer console for both Lightning web components and Apex. If I click here, you can see we can create an Apex class, we can create Lightning application, events, and Lightning components. But for in team development environment, you will do that within the Visual Studio Code with Git and other tools. So in this 12th step, it talks about that Apex is tightly integrated with the database. You can access Salesforce records and their fields directly from Apex. Every record in Salesforce is natively represented as an S object in Apex. That's the key for Apex and Salesforce data. This is how we instantiate an S object for the account with the new keyword and passing the attributes in the constructor. And we can do that same for the custom objects as well, and we can cast generic S objects to specific S objects types as well. Once we have a list of S objects, we can run DML operations with insert, update, upsert, delete, undelete, merge keywords, and there are some governance limits that we need to understand when we develop an Apex, which is and we need to go through some more detailed trail modules and some practice to really get into those understanding. So the limit is in place to ensure fair access to shared resources in Lightning platform. As you can see in this code snippet that we instantiate a contact record and created Josh as object for contact. Then we use the insert DML, and when we created we updated the description for the Josh object, and then we created another contact as object Kathy, and then we added that to the list of contacts here, and used the upsert DML notion in which Josh record has got updated and Kathy record has got created. So that's how we learn and understand Apex. And then there are it any operation DML operation, if it fails, it raises a DML exception, which we can use a try cache to cache that exception, just like we do in Java and other programming languages. And other than DML, we have database methods as well, which when we do bulk operations, depending upon if we want to continue in case of error as well, then we use database operations. And whereas with DML, if the error occurs, it stops, rolls back the transaction. We retrieve the records in Apex using the SOQL queries, and the syntax that we follow is we enclose the SOQL queries within the square brackets. And see in this we check on these, and this in this case we are creating the SOQL query to retrieve the name and phone from the account with this where clause, and we can write this SOQL query within the Apex code to retrieve the account records in the account list as object, and then we can use the DML operations and for loop to go over to iterate over the records. And there is a SOSL queries as well, which is based on Apache Lucene, and more for the finding the keywords, and more for the search and not for the DML or database operations, but more for the search operations. For that we write SOSL queries. And then this is basically about Apex basics and then we have since in Apex we work with the Salesforce data, we have a feature Apex triggers, which is again when the Apex triggers are useful, fun, and groovy. While this module helps you get started with them, it also references other Salesforce features to show you the power of Apex triggers. Apex triggers enable you to perform custom actions before or after event to the record. So let's just say if we have insertion, deletions, or updates, the Apex provides us the ability to write code before those database operations, and that's how we create the Apex triggers with we we write the trigger name with the object name and the trigger events, which the trigger events are before insert, before update, before delete, and after insert, after update, after delete, after undelete. And we can again use this snippets to get our hands dirty in the developer console. But again, it's as we use Apex triggers, we get more familiar with it, and then build patterns within the code, within the feature code that we implement. Similarly, there are bulk operations that we can perform, which helps us with the governance limits, and there are certain patterns that we need to follow while using triggers and performing bulk operations. Like we while before we perform bulk operations, we create a list of a subject and accumulate records in that list and then perform that operation. When performing DML calls in a trigger or in a class, perform DML calls on a collection of subjects when possible. Then there are bulk design patterns in action. Example of getting related records. Right, so just like for updates, we must figure out which existing accounts in the trigger don't already have a related opportunity. We can query the affected records from the database. Here's the SOQL statement, the results of which we assign to the to process list. Yeah, so this snippet of code, if we go through it, if we have created a add related record trigger on an account, and when we after the insert and the update operation on the account, if we don't have an opportunity, this trigger will add the default opportunity for the account. So that's how we can use triggers to perform operations after the DML, after the database records are getting created, deleted, or updated. So that's for Apex, and once we get into the Lightning Web Components basics, we go through this trail step, and we understand that that when we create the Lightning Web component, like in this example, we write the HTML and we write the JavaScript, just like in other frameworks like Angular. We have when we are creating a component, we use features like data binding and custom attributes, decorators, uh, in Lightning Web Component to create this UI custom UI tags which can uh, and once these are pushed to the org, then they can be included into the pages. So for and then Lightning Web Components are the uh, are the are progressive to the Aura components, and Aura components can include Lightning Web Components and not vice versa. So as we go through this trail step, we set up our workstation, we install the Visual Studio extension pack for Salesforce, and then we install the CLI, and we go through this trail step of creating a bike card project. So for example, we have created this where we have created a bike card class, the JavaScript class, and exported that, and we have assigned the default values for the attributes. Then we have used in the template we have created a div tag, and we use the metadata to push that to the org. And after that we go into the module, so we do these steps. And then when we have it also talks about the life cycle hooks which we can use, and decorators to when we do component communication. If we have a API decorator, then this attribute will be available to other components as well. And once we push the bike card component, we deploy that to the org with if you see, we can deploy this use this command to deploy the LWC to the source org, and we connect to the source org through the authorize and org command. And then once we do that, we have we can use this to open up the, or we can click on this Visual Studio Code feature to open up the org. And so here it talks about the component files which get pushed, and then configuration file is how we decide that the component is targeted for which Lightning page. Now, once we have the component available, we can add that component to the app pages. So in this case, if we go in Lightning App Builder, we will see that we have created a Lightning page, your bike selection, and we have made that a component we have added that component to this page, and then if you see, we have added this bike selection to the sales app. Which is and then we get into the multiple components and how we pass the event from the attributes from the event from the we when we click on the object in the parent component, then we pass the attributes into the child component. So that's how we understand the component relationships. So in with this example, we have a we see we have a tile component, the list component, where we display each object as a tile, and when we click on the tile, it communicates with the list component, and from there it connects. The data is passed to the detailed component, and let's just see if so if we look at this we if we look at this LWC basics bike selector trailhead component project, then we can see that we have a list component in which is a container component, and when we which is just calling the iterating over the data retrieved from this data file, and we are iterating over that in this bikes variable, and displaying that as a tile component, passing the values from the retrieved bike variable, which is here. And if we look at this then once we click on any of the tile, the event is emitted, and the name of the event is product selected, and we are passing the event detail in the detail object. Let's look at the tile component, which is like the on click event is calling the tile click event, and with that tile click event we are passing the event to the detail component, which is here. If you see that and we are setting the product ID through setter and then getting the product ID through the getter, which is how we communicate between components. Yeah, so this explains that we pass the events from child component to the parent component, and then properties are passed from parent component to the child component. But as we do more examples, we get better understanding on this component communication within the LWC framework. And then there is a component styling, which is standardized through Lightning Design System within Salesforce. Like in this case, we can use this SLDS text heading small, and then there are other classes that we can use to design our component UI. This is similar to Bootstrap, how we use Bootstrap. And then we have to learn about this decorators, which is based on the Lightning Design data service, and other decorators as well. And similarly, when we are designing our components, we got to make sure that they are designed for mobile friendly mobile friendly. The components are designed as mobile friendly. So that's about Lightning Web Components basics. So we have covered developer beginner trail, and then from here onwards we pick up on detailed trails on flows and Lightning Web Components, the Apex, the formulas and validations, and continue to develop expertise in Salesforce through TrailHack. Thank you very much. Thank you for listening.